Hi everyone. Today we're doing BJU Press Pre-Algebra section 3.4. It's called Simplifying Before Solving, and we're on page 134 in our book. We are starting with, I forgot to check the numbers. We're starting with 1 through 37 odd. All right, number 1, simplify each expression. So we have 9 minus 5c plus 8. This is just a little bit of a review back to like terms. So we've got, all right, like terms here would be our constants. We've got a 9 and an 8. The minus 5c is going to be by itself. And remember, we always write the things with the variables first, and then we write the constants at the end. So notice that the sign in front goes with it. So I'm going to keep that minus 5c, and then I'm going to add the 9 and the 18 to get plus 17. Number 3, 3a plus 4a minus b. Like terms have the same variable with the same exponents. So these are both a's. There's 3 a's and 4 a's. That makes 7 a's. And then we keep the minus b. Number 5, 12 times the quantity n minus 4 plus n. All right, in this problem, we're going to have to do distributive properties so we can get rid of these parentheses. And I know I need to do that because I've got an n here and over here, and they need to be combined, but I've got to get rid of the parentheses before I can combine them. So we're going to distribute the 12. That's going to give us 12n minus 12 times 4 plus n. So let me clean this up a little bit because I can do this 12 times 4. So I have 12n minus 48 plus n. Like terms, same variable with the same exponents. So here I've got 12 n's and I've got 1 n over here. Even though there's nothing in front, there's 1 there. So I know that it's a 1 in front. So that gives me 13n minus 48. Number 7, 3 times the quantity y minus 8 plus 3 times 2y. Again, I've got a y inside parentheses and here as well. I've also got a bunch of constant numbers, but they're all kind of mixed up here with parentheses. So my goal is to get rid of the parentheses. So that means I'm going to use the distributive property here with the 3. So I'll have 3y minus 3 times 8 plus, and here I'm just doing 3 times 2 times y, which is 6y. Notice I didn't distribute a 3 into these parentheses. That's because I had multiplication in the middle of the 2 and y, not minus. Plus or minus you would distribute. Otherwise, if you're just doing a multiplication in the parentheses, then you're just multiplying whatever's in there. Okay, so let's clean this up a little bit. 3y minus 24 plus 6y. Check for like terms again. Same variable with the same exponent. So 3y and 6y are like terms. That gives me 9y minus 24. Number 9, solve each equation and check your solution. So we've got 18x minus 4x equals 70. All right, so here's my equal sign. If I'm working on one side of the equal sign, I can just do any work I need to without having to do it on both sides. What I mean here is there's an x and an x that need to be combined together, but they're already on the same side of the equal sign. So I'm just going to go ahead and do 18 minus 4 and get 14x equals 70. Now I'm going to divide both sides by 14 because I have to move that 14 over. If I'm doing it on one side, I got to do it on both sides. Leaves me with x equals 5. We are supposed to check. Let's take the original 18x minus 4x equals 70. Plug in a 5, so 18 times 5 minus 4 times 5, and we're checking, does this equal 70? So 18 times 5 would be 90, minus 4 times 5 is 20. Does this equal 70? Yes, it does. That means we check, and our answer was correct. Number 11. 4 times the quantity 2x minus 3 equals 92. Okay, so here's my equal sign. There's two ways we could go about this. We could either divide both sides by 4, or we could distribute the 4. Either way, you're going to get the same answer. Let's go and do distributive property. Okay, multiply by 4, distribute, and multiply by 4. So that means we're going to have 4 times 2x minus 4 times 3 equals 92. Back to the left side, I've got a little work I could do here. 4 times 2x is 8x, minus 4 times 3 is 12. And keep my equals 92. Okay, so now I need my x. Keep in mind where my equal sign is. Next thing I'm going to do is add 12. Do it on both sides. 8x equals 104. Divide by 8. We're going to end up with x equals 13. And we need to check it. 4 times 2 times 13. Actually, let me write the original. 4 times the quantity 2x minus 3 equals 92. So we get 4 times the quantity 2 times 13 minus 3. And we're checking. Does this equal 92? We have 4 times the quantity 26 minus 3. Does this equal 92? 4 times 23. Does this equal 92? It does. 92 equals 92. Checks out. So we know our answer was 13. Okay, moving on to number 13. How does the distributive property help me solve equations? Applying the distributive property allows me to eliminate parentheses and combine like terms. So we can eliminate parentheses and we can combine like terms. Number 15. Write and solve an equation for each exercise. Find two numbers whose sum is 25 if the larger number is 4 times the smaller number. Okay, so they have two things going on here. They're telling us about a larger number and they're telling us about a smaller number. We need to come up with a variable for one of them. And I'm thinking, let's say that S is the smaller number. And we need to think about both of them in terms of the smaller number. And remember, when we don't know what the variable is, we have to start by defining it. So let's say that S equals the smaller number. All right, so I've defined my variable. So what I know is two numbers whose sum is 25. So I know I'm adding two things and I'm going to end up with 25. The larger number is 4 times the smaller number. So what that means is I have the smaller number plus the larger number, which we know is 4s. And now we can solve. So here's my equal sign. This s and this s, they're on the same side. That means I can just go ahead and combine them. They're like terms on the same side. Oops, I didn't actually combine them though. So there's one here. So that's 5s equals 25. And then divide by 5 on both sides. So the smaller number is 5. Number 17. Find a number such that 5 times the difference of 3 and twice the number is 27. Okay, so find a number. Let's just call it n. N equals the number. And what do I know? 5 times the difference of, oh boy. Okay, so I have 5 times, and I need to multiply it by the difference of 3 and twice the number. So it should look like this, equals 27. Let's use the distributive property to solve. 5 times 3, and then 5 times 2n. So I'm going to have 5 times 3 minus 5 times 2n equals 27. So give me 15 minus 10n equals 27. There's my equal sign. I've got my n over here. It's being multiplied by a negative 10 with a plus 15. Remember, you've got to keep the sign in front along with it. So this is grouped together. That minus goes with the 10n. There's nothing in front of the 15. That means we assume it's plus. In order to undo plus 15, we must do a minus 15. If you do it on one side, you do it on the other side. Keep that negative with you. That's going to get us 12. And then we're going to divide both sides by negative 10. So n equals 12 over negative 10. This is not reduced. If you're keeping it as a fraction, you must reduce it. We can keep it improper, however, which is when there's a bigger number on the top than there is on the bottom. If we reduce, we would divide both things by 2. That's going to get us 6 over 5. So you could have negative 6 over 5 as an answer. I would also accept negative 1 1/5 as an answer if you made it into a mixed number. Or you could even have the decimal, which would be negative 1.2. All of those are actually technically correct, and it doesn't really tell us how they want the answer, so I would take any of those. Number 19, solve each equation and check your solution. Negative 18 equals negative 4y plus 7y. Here's my equal sign. My y's are on the same side. They're like terms. They're on the same side. So I can just go ahead and clean those up. That'll give me negative 18 equals 3y. Divide both sides by 3. Negative 6 equals y. Maybe you went ahead and flip-flopped those. Then you would end up with something that looks like this. Negative 4y plus 7y. Notice I didn't change the order. I flip-flopped what's on the left and right side of the equal sign, but I didn't change the order. So if you went ahead and did this, then you would have 3y equals negative 18 and divide both sides by 3. Either one is correct. We're going to get the same answer at the end. It just depends on how you'd like to see it. If you want to keep your variable on the left side, you can totally move it over. All right, let's check with the original. So negative 18 equals negative 4y plus 7y. Let's plug in a 6, negative 6. Make sure you put that in parentheses so you don't get confused. So we have negative, oh, we're questioning this. We have negative 18 equals 24 minus 42, or plus a negative 42, however you want to think about it. And that does equal out, which means our original negative 6 was correct. Number 21. Negative 5y plus 2y minus 9 plus y equals negative 25. Wow, This is a big long train here. Okay, find your equal sign. Anything that's on the same side of the equal sign can be combined because they're like terms on the same side of the equal sign. So I've got negative 5y is like with 2y, which is like with y. If it helps you to block it off even, remember this sign in front goes with it. Even when you get down to this 9, it's going to be a minus 9 because the sign in front goes with it. So we have a negative 5, a positive 2, that's going to get us negative 3, and then a positive 1, that's going to get us negative 2y minus 9 equals negative 25. Okay, now we're back to isolating the variable. So what's going on with the y? It's being multiplied by 2, negative 2, and then a minus 9 from it. So the last thing first, that means we're going to plus 9. If we do it on the left, we do it on the right. That gives us negative 2y equals negative 16. Now we're going to divide by negative 2, and we're left with y equals 8. Let's check it. All right, original was negative 5y plus 2y minus 9 plus y equals negative 25. Plug in the 8. Negative 5 times 8 plus 2 times 8 minus 9 plus 8 equals negative 25. We're checking it. Gives us negative 40 plus 16 minus 9 plus 8. And does this equal 25? There we go. I'm typing it on my calculator. I'm trying to save a little time here. Got negative 25. It does equal negative 25. Okay, so test number 21. Let's move on to 23. We've got 3 times the quantity y plus 8 equals 39. All right, we need to use the distributive property. Let's distribute the 3 to both the y and the 8. So that'll give us 3y plus 24 equals 39. And we're back to solving this type of equation. So find your variable, it's being multiplied by 3 and then a 24 is added to it. Let's get rid of the last thing first. That means we have to get rid of the plus 24 by doing minus 24. If you do it on the left, you do it on the right. That leaves me with 3y equals 15. So 3 and y are being multiplied. That means we have to undo multiplying by 3 by dividing by 3. Do it on the left, do it on the right. You get y equals 5. Let's check. 3 times the quantity 5 plus 8, does this equal 39? It's going to give us 3 times 13. Does that equal 39? It does. 39 equals 39. Number 25. 4 times the quantity x minus 23 plus 3 times negative 2 equals 2. All right, lots of cleanup work to do. Here's my equal sign. Let's distribute first. So we're going to have 4 times x minus 4 times 23, and I'm going to write this as minus 6 equals 2. It's a negative 6, but hopefully, as we were talking about in class, you have to be able to know when to switch between plus the opposite and minus, back to a minus. This would be a case where you'd want to. All right, so we've got 4x minus 92 minus 6 equals 2. Like terms here with these constants. There's no variable attached to those, so you can go ahead and add them. However, the 4x needs to stay because it's got an x attached to it. Keep in mind that these are really plus the opposite plus the opposite. Here's another case. Oh, I ended up switching it back to plus the opposite anyway, so I could do this adding. You have the same sign, which means you find the sum. That's going to be 98. And then you keep the sign. Equals 2. Notice I switched right back to minus instead of plus and negative, because now in the setup of my equation, I don't want to have to deal with plus and negative and then try to figure out, am I supposed to do the inverse of plus or minus? So if you just go ahead and switch it back to the minus, then it makes it really clear that you need to add 98. That's the inverse. So 4x equals 100. We're going to divide both sides by 4 and get 25. All right, number 27. 2 times the quantity x plus 3 plus the quantity x plus 3 equals 3. Let's distribute. Here's my equal sign. I can distribute this right like that. So I'm going to have 2x plus 2 times 3. Now, when I come over here, they have this x plus 3 in parentheses, but honestly, we don't really need it because in front of it is a plus sign, plus 1, technically. And if we distribute a 1, that means we're going to end up with the very same thing that's in the parentheses, and I don't even think we need it at that rate. Let's go back to the beginning. 2x plus 6 plus x plus 3 equals 3. Where are our like terms? So I've got x and x. I've also got constant and constant. Okay, this one doesn't have a number in front. We know it's a 1. That means I've got 2 x's plus 1x. That's going to be 3x. Then I've got a 6 and a 3. So that's plus 9 equals 3. All right, now I'm going to minus 9 on both sides. 3x equals negative 6. Divide by 3 on both sides. X equals negative 2. Number 29. Quantity 3x minus 1 minus the quantity 4x minus 12 equals negative 7. Tricky here with these parentheses. So I don't see anything in front of this, right? That means I don't really need the parentheses here. There's a 1. If I distribute a 1, I'm not going to change it. 3x minus 1. This next group of parentheses is a little different. This one has a minus. If we throw a 1 there, because there is one of that parentheses, because that parentheses exists, so there is 1. So we put a 1 in front. That means we've got plus a negative 1 being multiplied to it, which is going to distribute across. So basically you just change the signs inside the parentheses. But you can think about it like multiplying it by a negative 1. So negative 1 is going to distribute, which is just going to change the sign inside the parentheses. So it's still going to end up being minus 4x and a plus 12 equals negative 7. Okay, let's look for like terms on one side of the equal sign. I see a 3x. I see a negative 4x. Those are like. I see constants negative 1 and positive 12. So 3x and negative 4x is a negative x. Negative 1 and 12 is 11. That equals negative 7. All right, minus 11 on both sides. Keep that negative in front of the x. Equals, we've got the same sign, so we find the sum keep the sign. When you have a negative x on both, negative x and negative 18, it's, you know, you could just take the negatives out and get positive x equals positive 18. Really what you were doing, the math behind it, not everybody writes that, but the math behind it would be dividing both sides by -1, which gets you 18. Number 31. Is that what we're supposed to do? Where's my list here? Yeah, 37 odd. Okay. Write and solve an equation for each exercise. Mr. Oldenburg's boat cost 4 times as much as his trailer. If the difference in price was $2,400, what was the cost of each? Okay, so we have an idea that we need to know the cost of the boat and we need to know the cost of the trailer. The thing is, we can't make a variable for both of them. We have to just come up with one variable and then decide how to talk about the other piece of equipment in terms of one variable. So why don't we stick with the trailer? Let's call it T as our variable, and T will be the cost of the trailer. So what do we know? His boat costs 4 times as much as his trailer. If the difference in price was $2,400, what is the cost of each? So I know that I have a difference, which is minus, and then it says the difference is or equals $2,400. Now I just have to figure out, what am I minusing? I am minusing 4 times the cost of the trailer and the trailer, right? Because 4 times the cost of the trailer is what the boat cost. So 4t minus t equals 2,400. There's my equal sign. Just so happens that these t's are on the same side of the equal sign, which means that they are like terms. I can go ahead and combine. That gets me 3t equals 2,400, and I'll divide both sides by 3. That's going to give me $800. But it says what's the cost of each one. So y, oops, I wrote a y. That's supposed to be a t. So t is the cost of the trailer. So let's just say trailer is 800, and then boat is 4t, which is 3,200. Number 33. On a multiple choice exam, Dr. Guthrie gives 2 points for a correct answer and -1 point for a wrong answer. No points are given for an unanswered question. Jeff left 2 questions unanswered, missed 6 questions, and received 82 points on the test. How many did he get right, and how many questions were on the exam? Right, so the question that we need to start with is, how many did he get right? If we can answer that, then we can be able to figure out how many were on the exam altogether. So let's come up with a variable for the number of right answers. We'll call them R. R stands for the number of right answers. Okay, so we've got 2 questions unanswered and 6 missed questions. So how are we going to do this? Okay. Two points for each correct answer. A negative point for the wrong answer. No, okay, so actually no points are given for the unanswered one, so that really doesn't matter. But we do know that he must have gotten some of them right, and all the ones that he got right, he got 2 points for. So we got a 2R. The 2 questions unanswered are 0 points anyway. So I mean, I guess you could go ahead and write the 0, but it doesn't really matter. And then the missed questions are 6, but he gets negative points for that. -1 point for that. And then he ended up with 82 altogether. Okay, so let's clean this up a little bit. So we got 2 for each right. We don't need the 0. This is going to be minus 6 equals 82. Let's see if this works. So we got to add 6 on both sides. That means 2r equals 88. Divide by 2. R is going to be 44. So we know there are 44 correct answers. But we also need to know how many were on the test. So how many were on the test altogether? He had 2 unanswered, 6 that he missed, and 44 that he got right. So 44 plus 2 plus 6 equals 52. Okay. So that one was a lot, man. Let's see, one more word problem. Mrs. King bought 6 pounds of steak and 20 pounds of ground beef. The steak cost $5 more than the ground beef, $5 per pound more than the ground beef. And the total bill was $82. What was the price per pound for each type of meat? So remember again, you're asked for 2 things in this problem, but you can only use one variable or you're not going to be able to solve your problem. So what is the price per pound for each one? We have to make a decision. Let's just go with the beef. Let's say X equals price per pound of ground beef. Okay. The steak costs $5 more for the ground beef. I might even write this down here. Just like as a note, if we take our ground beef and we add 5, that's going to give us the price per pound of steak. So I am coming up with two quantities here using the same variable. That has to be your goal when you're solving equations like this and creating these word problems. Otherwise, you can't have 2 different variables just because you have 2 different kinds of meat. You have to get them to both be talking about the same variable. Okay, so moving on. 6 pounds of steak. So that's going to be 6 times x plus 5. And what else? 20 pounds of ground beef. That's going to be 20x. And the total bill is $82. Okay, here's my equal sign. I've got some like terms on the left side I need to combine before I do anything else. Let's distribute to get rid of parentheses. 6x plus 30 plus 20x equals 82. Still going, like terms. Before I do any of the solving, inverse operations, any of that jazz, I need to clean up all my like terms on the same side of the equal sign. That means I've got 26x plus 30 equals 82. Okay, minus 30 on both sides. 26x equals 52. Divide both sides by 26. X equals 2. So what's the question? What was the price per pound for each type of meat? So it's $2 per pound for the ground beef, which means it would be $7 per pound for the steak. What was the price per pound for each type of meat? Okay, cool. All right, I think we are almost finished with these. What are we working on here? 37 yet. Solve each equation. X plus 2x all over 3 minus 16 equals 45. Okay, there's my equal sign. So I got to clean up everything on the left first. All right, so here's a grouping. It's grouping these like terms, x plus 2x together. So 1x plus 2x is 3x over x minus 16 equals 45. Now I've got 3 over 3. That's a little messy. Clean it up. They cancel each other out. Notice I'm not doing it on both sides because I didn't have to change. I didn't do it on the entire side. I just did it to the x's there. Add 16 on both sides to solve this out. X equals 61. Okay, now we're skipping to 43 to 47 odd. Number 43. Write a squared b to the negative fifth with only positive exponents. Oh boy, this is an old one already. Okay, so positive exponent, the a squared is already positive, so it doesn't have to get moved anywhere. But the b has a negative 5, which means you just have to throw it down in the denominator, and now it becomes a positive 5. Number 45. Evaluate each expression. X times the quantity 4 plus y. When x equals negative 1, y equals 5. Okay, so x is negative 1 times the quantity 4 plus y, which is 5. Do the inside here first. So we have negative 1 times 9. The answer is negative 9. And 47. Write each number in scientific notation. My word, I gotta copy this down here. I think that's right. So let me see, this is hundreds, thousands, millions. So 6,700,000,000. Okay, so I need the decimal to be here. So 6.7 times 10. I need it to be there. Let's take it from where we need it to where it's going to go, or where it was. This is where we need it to be. Where was it? 1, 2, 3, 4, 5, 6, 7, 8, 9. To the right. So that's plus 9. Actually, you don't really need the plus in there. If there was a minus, you would need it, but you don't really need the plus in there. Not wrong if it is there. Okay, let me see what was next here. So 48 and then 51 and 52. Okay, how many zeros? 1, 2, 3, 4, 5. And then 725. Okay, so we're going to have it be 7.25. This is where I want it to be. Let's see where we came from. 1, 2, 3, 4, 5, 6. 6 to the left, so negative 6. Oh my word, I keep forgetting. 51 and 52. What would be the first operation performed on each side to solve 3x plus 8 equals 20? Would we multiply by 3? No, we would not. Would we add 8? No, because we're already adding 8. Would we subtract 20? Nope, that's on the other side of that's not even on the same side as the variable. Would we multiply by 8? No, because we're not dividing by 8. That means it's going to be none of these. Bonus points if you actually can say what it is. It would be minus 8. Minus 8 on both sides, but that wasn't an answer. Okay, number 52, solve this. Negative 7x minus 12 equals negative 47. Okay, we're going to add 12. Negative 7x, and we're going to have to subtract because the signs are different. It's going to end up with a negative 35. Remember to keep those negatives with you. Negative 35 divided by negative 7 is a positive 5, which means the answer is C. There we go, another one down.